Okay, just to finish that up and get the last slide in there real fast. So we have done all that. We ended up working all of that. Where I left you was figuring out the terminal voltage. So that's the EMF minus the I total times the little resistance. So the EMF was 9, the I total was 0.89, and the little resistance was a half. So you can figure out your terminal voltage that way. And the current through the 6 ohm resistor is going to be a little trickier, but not impossible. You can do, if you remember that entire parallel part, that entire parallel part was equivalent to 4.64. And then you still had the 5 ohm that was over here and the half ohm that was down by the battery. And so if you do the 5.64 times 0.89, you can get the voltage for that entire parallel part. And then if you look at that parallel, it's a 10 up top, and then a 6, and this other thing down here that was equivalent to 2.67. 2.67, right? So you had 8.67 down here on the bottom. So you can do, this total was 8.67. So once you know the voltage on, I'm sorry, this is 2.64 ohms. I don't want to confuse you. So 2.64 ohms here. Once you know the voltage on this entire branch, which you can get by 4.64 times 0.89, that'll get you the voltage there. Then that voltage is the same top and bottom. So you can take that voltage and divide by whatever this voltage is, divide it by 8.67 and get the current down low. If you divide it by 10, you'll get the current up top, and those currents should add to 0.89. So whatever this voltage is, it's going to be something like, I don't know, whatever that is, around 4-ish. You can take that voltage and, again, divide by the total resistance down low, and that'll give you your current down low. So then the last thing is, pardon the interruption. The last thing is just a reminder of how we find power and energy for a circuit. So power is current times voltage, and energy is power times time. You can find power for the whole circuit if you wanted to. You can find total power by using total current and total voltage, or you can find individual powers for pieces of the circuit by doing individual currents and individual voltages. And then energy for the circuit is the power, the total power of the circuit times the time that the circuit is run for. And usually for these purposes we'll use joules. So we'll put the power in watts and the time in seconds, and you'll get your answer in joules or kilojoules or something along those lines. So that is just a reminder of how we do the power and the energy in an electrical circuit. And that's it.